In this lecture, we will see the block diagram and the ideal characteristics of operational amplifier. Let us look at the definition of OpAmp. It is basically a direct coupled very high voltage gain amplifier. What is the meaning of direct coupled? The output of one stage of the amplifier is connected directly to the input of next stage without any coupling capacitor, hence called direct coupled amplifier. The meaning of that is between the two stages of the operational amplifier there is no coupling capacitor. Next, the word operation in OpAmp stands for mathematical operations such as addition, subtraction, multiplication and division. OpAmp performs all these operations, hence called operational amplifier. Next, we will move on to the block diagram of operational amplifier. The block diagram of OpAmp is shown in figure. It consists of 4 stages. The first 2 stages are differential amplifiers. They provide very high voltage gain and high input impedance. This is how a MOSFET based differential amplifier looks like. At the input there is a MOSFET whose structural diagram is shown here. The reason for high input impedance is at the input of the MOSFET there is a metal oxide semiconductor configuration. Oxide being insulator which does not allow any flow of charge carriers, hence acts like a resistor with infinite impedance. I hope you understood the reason why OpAmp has very high input impedance. The next stage is a buffer or voltage follower. It also offers high input impedance to prevent OpAmp from loading. Also, this stage adjusts DC voltages so that the output voltage is 0 for 0 input voltage, meaning when there is no input voltage signal, there is no output. That is, the output voltage of the operational amplifier is 0. The last stage of the operational amplifier is to provide low output impedance to the operational amplifier. These are the 4 stages of operational amplifier. Next, we will move on to the circuit symbol of operational amplifier. It has primarily 2 input terminals, 1 output terminal and 2 terminals for power supply, positive supply and negative supply. Inverting input terminal is represented by V minus and non-inverting input terminal is represented by V plus. The meaning of inverting terminal is if we apply a positive voltage at the input, that is the inverting input, the output voltage is negative. If you apply a negative voltage at the input, output voltage is positive. If we apply a sinusoidal voltage at the inverting input, there will be a phase shift of 180 degrees at the output waveform. That is the meaning of inverting terminal. There is no such a phase shift in case of a non-inverting terminal. Next, we move on to the ideal characteristics of operational amplifier. The first one is the open loop gain of the operational amplifier is infinite. That is very high voltage gain. The input impedance of the operational amplifier is infinite. The output impedance is very low or it is 0. These points we have discussed while discussing the block diagram of OpAmp. Coming to the next important characteristic of OpAmp, it must have high bandwidth. That is, the bandwidth of Ideal operational amplifier should be infinite, meaning the op-amp should be able to amplify signals over a wide range of frequencies with high gain. Also, the operational amplifier should have zero offset, meaning when there is no input signal, there should not be any output signal. But the question is, why should there be any output when there is no input signal? There can be some voltage at the output because of supply voltage. An ideal operational amplifier should have zero output voltage when there is no input voltage. In summary, we have looked into the block diagram and the ideal characteristics of operational amplifier. Thank you.